Today I will be showing you how to do an ANOVA, which is from Chapter 12 of the textbook for Psych 241. ANOVA stands for Analysis of Variance. It is used to evaluate the mean differences between two or more treatments. You might be wondering why you would use an ANOVA over other tests. ANOVAs can be used in situations where there are two or more means being compared, whereas the other tests, such as the t-test, are limited to situations where there are only two means involved. ANOVAs also protect researchers from the type 1 error, which is when the null hypothesis is wrongly rejected when it is in fact true. So ANOVAs kind of make researchers more credible. Researchers can also evaluate all of the mean differences in one hypothesis test, so you can get more results from one test. ANOVAs are also a form of hypothesis testing, and there are 4 steps that are outlined in Chapter 12. And these are the 4 steps, and I'll explain them and some of the terms that come with them, and then we will apply the steps in an example that is to follow. So step 1 of the hypothesis testing would be to state the hypotheses and specify the alpha level. There are 2 hypotheses that we'd have to state, and that is the null hypothesis and the alternative hypothesis. Step 2 would be to locate the critical region. And in this step, we will figure the degrees of freedom, which is the number of values in the final calculation of a statistic that are free to vary. I also want to point out 2 terms that you'll begin hearing in this step that will follow in the steps to follow step 3 also. You'll hear between treatments and within treatments. Between treatments refers to the differences from one treatment to another, whereas within treatments refers to the differences that exist inside of the individual treatment conditions themselves. Moving on to step 3, we would start to perform the actual analysis. We'll figure the sum of squares, which is represented by capital S, capital S. We'll find sum of squares within treatments as well as between treatments. We'll also analyze the degrees of freedom that we found. Then we will figure the mean of squared deviations, which is represented by capital M, capital S. And mean of squared deviations refers to the variance of the treatments. The final thing we'll figure in step 3 is the F ratio, which is what we will use to reject or accept the null hypothesis based on where it sits in the critical region or outside of the critical region. And the final step of the hypothesis testing would be to make a decision about the null hypothesis, or HO, and to state a conclusion from our research. Now we're going to do an example. This slide will explain what we are looking for and what the data is representing, and the data will be given on the following slide in a chart. An educational psychologist studied 3 types of books: paperback, hardback, and ebooks. 3 samples of students were given a particular type of book, and the number of miscues committed by each participant was recorded. Here's the data for the example. Treatment 1 will refer to the paperback books. Treatment 2 will refer to the students who were given the hardback books. And treatment 3 will be referring to the children that were given ebooks to read. And the numbers under the treatments are referring to the miscues that these students committed. I went ahead and figured the mean value for each treatment, as well as the t-value, which is the sum of the miscues, as well as sum of squares for each treatment. And you'll need these values in the later calculations. I also went ahead and gave you N, which is the total number of participants, G, which is the sum of the t-values, and I also gave you sum of x squared, which you'll be using to figure the sum of squares. So go ahead and take a minute and either screenshot the data or write it down. I'll assume you've done that. So to start the hypothesis testing, or the ANOVA, we will state the hypotheses and specify the alpha level. The null hypothesis for this treatment would be HO is the mean of treatment 1 equals the mean of treatment 2, which equals the mean of treatment 3. And we can interpret that as the type of book used has no effect on the amount of miscues that is committed by each student. The alternative hypothesis, which is represented by H1, would be that at least one of the treatment means is different. And the alpha level we're going to use for this example is 0.05. This is a typical alpha level for ANOVAs. Moving on to step 2, we're going to locate the critical region. As I mentioned, you'll be finding the degrees of freedom between treatments as well as the degrees of freedom within treatments. I've highlighted the equations in blue in the answers on all the slides just so they're more noticeable. So to figure degrees of freedom between treatments, we would take K, which is the number of treatments, minus 1. So we have 3 treatments, take away 1 and get 2 for the degrees of freedom between. To figure degrees of freedom within, we would take N, the total number of participants, which is given to you on the first slide, minus K, the number of treatments again, which is 15 minus 3, and we get 12 for the degrees of freedom within. And to find the critical F value, or our critical region, we would look at table B4 on page 577, which is in the back of the textbook. You'll find the degrees of freedom between on the top and the degrees of freedom within on the side, and you'll find 2 and 12, bring them together, and find that the critical F value for an alpha level of 0.05 for this particular example is F equals 3.88. So our critical region is 3.88. Moving on to step 3, we'll start performing the actual analysis. And as I mentioned previously, we will begin with the analysis of the sum of squares. Once again, the equations are highlighted in blue as well as the answers, just so they're more noticeable. So to find the sum of squares total, we would take sum of x squared, given to you on the first slide, minus g squared, also given, divided by n. So plug in those values and you'll get 46. The next sum of squares we will find is SS within, which is the sum of squares inside each treatment. So as I said earlier, the sum of squares between the under the table for each treatment was given. You'll add those values to get the sum of squares within, which is 36. The last sum of squares we have to find is the SS between, which to figure that you would take the SS total minus SS within. So plug in 46 and 36 and get 10 for SS between. The next step in step 3 would be to analyze the degrees of freedom that we found, and we also have to find one more. So we will find the degrees of freedom total. So take in the total number of participants minus 1, and you get 15 minus 1, you get 14. And then also we would again state that our DF between is 2 and DF within is 12. Moving on to the next step of step 3 would be to calculate the MS values. To figure MS between, we would take the sum of squares between divided by the degrees of freedom between. So take the 2 former values that we figured and plug those in. So for SS between we figured 10 and DF between we figured 2. 10 divided by 2 is 5. That is our value for MS between. For MS within, you would take sum of squares within divided by the degrees of freedom within. Plug in those values, 36 divided by 12, and get 3. So MS between, take sum of squares between divided by degrees of freedom between, and the same for MS within, except you'll use sum of squares within divided by degrees of freedom within. The final step of step 3 would be to figure the F ratio. And to figure the F ratio, we would take MS between divided by MS within. So the values we just previously figured on the previous slide. So MS between was 5 divided by MS within of 3 equals 1.67. So our F value for this example is 1.67. And the final step of this ANOVA would be to make a decision about the null hypothesis. So we found that our F ratio was 1.67, which is not in the critical region because it does not exceed 3.88. So say we would have found an F ratio that was larger than 3.88, then we would have to reject the null hypothesis. But because we have found 1.67, which is not in the critical region, since it doesn't exceed 3.88, we have failed to reject the null hypothesis. So we would interpret that as the type of book does not have a significant effect on the number of miscues committed by students. And this final bit of information highlighted in red would be how you would report your findings of this example in the report for the ANOVA of this example. Thank you.